Welcome to another edition of my tutorial. If you are new, you're welcome, and if you're old, you're super welcome. Today's video is concerned with how to graph the line of best fit. Line of best fit, also known as regression line, is a straight line that fits best when drawn through the points. Previous videos already established that line of best fit is used for making prediction or estimates. Without wasting much time, let's jump on the challenge we have on the board. The challenge says, the table below shows different concentrations in volume per unit weight of liquid fertilizer, of course representing the x variable, and the height in centimeter of maize plants representing the y variable, obtained 2 weeks after planting in a sample of 6 plots of farmland by a plant scientist. Given that the equation of line of best fit, also known as regression line of y on x, is y equal 2.1833 plus 0.053x. The questions are: A. Plot the scatter diagram of the observed data values. B. Draw or graph the line of best fit, also known as regression line of y on x, on the scattered diagram. The table here shows the 6 plots of land and different concentrations of fertilizer representing the x series, plant height represents the y series. Going by what the first question says, we are expected to plot these values in a graph sheet, right? And there we go now. Concentrations of fertilizer from 0 to 100 on the x-axis, the plant height on the y-axis. Now let's go back to our table. When the concentration of fertilizer is 0, plant height is 2.1. So we'll plot that on our graph. 0, and so 2.1 will be somewhere around here. When x is 20, y is 3. We trace that now. 20, y is 3.1. 3.1 will be here. Going forward, when x value is 40, y value is 4.3. 40, 4.3. 4.3 will be around here, right? So when x value is 60, y value is 5.7. 60, 5.7. When x is 80, y is 6.4. I have 80 is to 6.4 here, right? When x is 100, our y value is 7.3. 100 here, 7.3, somewhere around here. We succeeded in answering the first question, which asks us to plot the observed data values. Now let's proceed to the second question. Second question says, draw or graph the line of best fit of y on x on the scattered diagram. To achieve this test, we'll make do with the regression equation given to us, right? There we go now. This is the regression equation, or the equation of line of best fit given to us, which is y equal 2.1833 plus 0.053x. Alright, looking at this equation, we could see our s variable, that is the independent variable. Now, basically what we'll do is, we take the least value of x here in the table. The least value here is 0. You substitute it into the equation. The equation becomes y equal 2.1833 plus 0.053 times 0, right? We did say the least value is 0. So y value becomes 2.1833 plus 0.053 times 0. 0 here. Our y value becomes 2.1833 plus 0, which is 2.1833. Now we trace this value in our graph. There we go now. By our calculation, when x is 0, we got our y value to be 2.1833, somewhere around here, right? Next is to take the highest value of s. Of course, in this series, we are having 100 as the highest value and substitute it into the equation of line of best fit. Here we go now. Y becomes 2.1833 plus 0.053 times 100, right? Y becomes 2.1833 plus 0.053 times 100 gives us 5.3, and so y value becomes 2.1833 plus 5.3, which gives 7.4883. So we've used the value of x to predict the value of y. So we trace this value on our graph. Here we go now. When the value of x is 100, the predicted value of y is 7.4833, somewhere around here. The last step is to take the two middle values of s. Of course, the two middle values of s here on our table is 40 and 60. Right, 40 plus 60 gives us 100. So we divide 100 by 2. 100 divided by 2 will have 50. So we'll have this as the main value of x. We'll substitute this into the equation of line of best fit. Y becomes 2.1833 plus 0.053 times 50. So y equals 2.1833 plus 0.053 times 50 gives us 2.65. And so the predicted y will not be 2.1833 plus 2.65, 4.833. So we trace this on our graph. The mean value of s will get 50, which will be around here, right? We trace the predicted value of y, we got 4.833. We move now. So 4.833 is somewhere around here, right? So we draw the equation of line of best fit by joining the predicted y values, that is the point of blue, together, right? Here we'll go now, trying to join the 3 points together. So this is what our line of best fit looks like. So we've succeeded in answering all the questions. I hope this video is helpful to everyone. Please do well to like this video, leave a comment, share, and subscribe to my channel. Thank you so much for watching. Bye.